Hello students, so let us discuss one more important concept. So inside your conservation law is, that is the law of conservation of energy. So before discussing the law of conservation of energy statement, let us discuss the different types of energy that we have observed in our daily life. Okay. So what do you mean by energy? Energy is the capacity to do the work. So for everyone, for everything, we require an what? Energy. So energy is the what? Is the capacity to do the work. So there are various types of energy associated with the body, such as heat energy, light energy, sound energy, elastic energy, chemical energy, atomic energy, and mechanic energy. So we are having what? Different types of energies. Okay. Though there are so many types of energy, the energy in one form can be transformed into other forms. In a dynamo, what happens? A mechanical energy is converted into electrical energy. That means one type of energy, mechanical energy, gets converted into what is electrical energy. Whereas in steam engine, heat energy is converted into what is kinetic energy. In an electric pulse. So this is a good example for energy. In your electrical bulb, what happens? There, that the electrical energy is converted into a light energy and a heat energy. So here, I'm seeing all these things. So one form of energy is gets converted into another forms. So based on which there are two types of energy. So that is kinetic energy. The second one is the total. It's what is a potential energy. So therefore, the total energy of the body or object is equals to the sum of kinetic energy and a potential energies. So what do you mean by kinetic energy? It is the energy possessed by an object or the particle by virtue of its motions. It is what? The energy exhibited or possessed by the object due to its what? A motion is nothing but a kinetic energy. Whereas potential energy is again an energy, so possessed by your object by virtue of its what? Positions or due to its positions that object exhibits or produces a what? A certain amount of energy. So that energy here we are calling it by what it is? Potential energies. Okay. So let us illustrate how that energy is conserved in our universe or in our what daily life. Okay. So we know that if an object or a body is raised, means it is lifted to a certain height and kept there, that object has purely a potential energy. Here, what we are doing is we are lifting an what object to a certain height. There, that object has purely a potential energy. Suppose if it is allowed to fall down, its potential energies reduces and the kinetic energies increases. And in this case, the potential energy is not destroyed. The potential energy is what? Not destroyed, and kinetic energy is not created. So, but potential energy is converted into kinetic energies. During its motion, the body has both potential energy as well as kinetic energies. On striking the ground means when it reaches the ground, it has purely kinetic energy and the potential energy becomes what it is zeros. When it is exactly at a certain height, there that object has purely potential energy. When it is allowed to fall, the potential energy of that object goes on decreases, but its kinetic energy is what increases. When it reaches the ground surface, its potential energy is completely becomes what is zero, and the kinetic energy is what is increases. So in these discussions, whatever I have told here, one form of energy has been converted into what is another form. So that I already mentioned in the beginning. In bulb, that electrical energy gets converted into light energy, and one more is what heat energy. And in steam engine, so what happens there? That heat energy is converted into kinetic energy. In the same way, in case of dynamo, that mechanical energy is converted into what is electrical energies. So on the basis of this one, the law of conservation of energy is stated as energy is neither created nor destroyed. This is one way of defining or one way of stating that law of conservation of energies. So in one more way, the total energy of an isolated system remains constant. You can say it like this also, or the sum of all the energy in the universe remains constant. This is one more way. Our energy is always conserved. What it is? The energy is always conserved when transformed from one form to what? Another form. Whatever that energy, in case of your dynamo, that mechanical energy is converted into what is electrical energy. So that the energy remains constant. That's why. So it is termed as what? Energy is always conserved when transformed from one form to what? Another form. So this is the what? Statement of your law of conservation of your what? Energies. Okay. So let us illustrate how that energy remains constant in case of a freely falling object, freely falling bodies. So this is the surface is at a height of what? H from the ground surface. So initially that object A is at a height of H from the ground surface. That object is what? On this rigid support or on this surface at a distance of what? H from the ground surface. So when it is at the point A, that object has purely potential energy and it does not have what? Any amount of kinetic energies. Okay. So when this object, so see here, now let us prove that above laws is holds good in the case of what's freely falling bodies. Let a body of mass m placed at a height of what is h above the ground, when it starts falling down from the rest, in this case, we have to show that the total energy, that's what potential energy plus kinetic energy of the body, it was a constant at the point of A, B, and C. So wherever you are choosing on its path, the total energy of that object should remain constant. Okay. So that is potential energy is completely transferred towards kinetic energies. So now we have to consider the object at the point of what is A. That body of mass m placed at a height of what is h. When it is at the point A, the potential energy of that object is mgh. So on the surface of that on the surface of that on this the object is on the some surface. Initially it is at rest. So that when it is at rest, the velocity is zero, then kinetic energy becomes what is zero. So that the total energy of that object is equals to what? Potential energy plus kinetic energy, but here kinetic energy is zero, so that the potential energy of that object is mgh. So the total energy at the point A equals to what it is? mg into h. Okay. Next, when that object is allowed to fall freely, that means when your object is at the point of what is b, when it is at the point of what b, so the distance moved by your object from a to b is you take it what x. Okay, it is what is x. Then the distance of this one is bc is what h minus x is. Okay, so see here, when your object is at the point b, the potential energy of that object from the ground, it becomes what is mg. Actually it is h. Here h is, that's already how told that it is moved, it is displaced to a distance of x. So that height of that object from the ground is h minus x. So potential energy is equals to what? mgh minus of mgx. And its kinetic energy, it's what it is? It's having motion. That means it's falls freely from the it moved from the point A to B. That's why it's having velocity. So its kinetic energy equals to half m into of this. So during this time, the body covers the distance x with a velocity v. By making use of your third equation of motions to obtain the velocity of the body, so you want to insert that u is equals to 0 and a equals to z and what s equals to x. So there, so we are getting what? That kinetic energy is equals to mg into x. So these things you want to substitute in Newton's third equation of motion, the third equation of motions. So then you will get, and what the kinetic energy is equals to what is mg into ix. So therefore, the total energy at the point B equals to potential energy plus of what is kinetic energy. So the total energy at the point B equals to mg into what is h. Again, it becomes what is h. Okay. Next, what about at the point of what stage? So here the potential energy of that object when it is reaches on the ground surface, it is h is 0. So that's why it becomes what? mg into 0 equals to 0. The kinetic energy of that object is half mv square. The freely falling body has covered the distance of what h. Here u is equals to 0 and you write what? A equals to g and you also put what? S equals to what? H. So the kinetic energy becomes what is the half mv square. Half mv square. Then the kinetic energy becomes what? Mg into h. So therefore, the total energy at the point C is again it is given by what? Potential energy plus kinetic energy. Potential energy is 0. So the kinetic energy is mgh. So therefore, the total energy of your object at the point C equals to what? Again is what? M into G into H. So by seeing the all these 3 points from the equations 1, 2 and 3, so there we conclude that the total energy of that body remains constant at every point along its path. So we conclude that law of conservation of energy holds good in the case of what is freely falling bodies. Okay. So the examples for your law of conservation of energies are what is you can say it is what is in a torch. The chemical energy of the battery is converted into what it is electrical energy. So in this case, what? In torch, the chemical energy of the battery is converted into what? Electric energy, which is converted into what? Light and heat. In loudspeaker, in what is loudspeaker? So we are having what is electrical energy is converted into what? A sound is. Okay. And one more thing, in case of your what? Microphone, the sound energy is converted into what? Electrical energy. In a generator, the mechanical energy is converted into what? Electrical energy. And when fuels are burnt, chemical energy is converted towards heat and light energy. Chemical energy from one food is converted into what? Thermal energy when it is broken down in the body and is used to keep its what warmth. Okay, so these are the few examples of what is the law of conservation of energy, so that we are observing in our what a daily life is. Okay, so we will discuss one more important concept in the next class. Thank you.